fellow mathematicians. Welcome to the podcast where math is figure-outable. I'm Pam.
And I'm Kim.
And we're here to suggest that mathematizing is not about mimicking or rote memorizing, but it's about thinking and reasoning, about creating and then using mental relationships. That math class can be less like it was for so many of us, and more like mathematicians working together. We answer the question, if not algorithms, then what? All right, y'all. Very excited today for our episode. I got an email recently from a colleague who said, quote, I had the most amazing time this morning working through partitive and quotative division, with two sixth graders who just wanted to work with division today. One asked me where she could buy Building Powerful Numeracy. She had her teacher's copy and was reading about division. Can you believe that? All right, awesome. So cool. I appreciated receiving that email. That was kind of fun to hear about that. So yeah, I have a book called Building Powerful Numeracy. You might want to check it out. It's a good read. I don't know that I ever had intended for students to read it, but bam, by all means, anybody's welcome. I think it's a pretty good read. So cool.
Yeah, so good. Okay, so in the last few weeks, we've been talking about fractions.
Fractions!
Right? Woo. And in the last two episodes, we dove into using a money model to help students find equivalent fractions.
Mm-hmm.
And with equivalent fractions, addition and subtraction becomes doable, more figure-outable.
Yeah, and so you might have noticed that we were talking about equivalence and helping students develop equivalence with fractions, but then we quickly started doing addition and subtraction with fractions. It might have looked like or sounded like teach equivalence and then teach addition and subtraction of fractions. However, what we're actually suggesting is that you use adding and subtracting fractions to help teach equivalence.
Mm-hmm.
So we did a little bit to think about fractions with money, but then we quickly dove into adding and subtracting fractions for which you had to think about equivalence in order to solve. That gives all sorts of experience with why we even need equivalent fractions and in finding equivalent fractions and then using them to add and subtract. That might be a little bit of a new idea for you, that It's not about just teaching. In my traditional experience, we sort of taught kids the rule about how to find equivalent fractions because they needed a common denominator.
Mm-hmm.
And we did that rule and they memorized that. And then we sort of said, okay, now when you add and subtract, thou shalt find a common denominator. Instead, we're just giving them a problem and we're asking them to think about money.
Right.
And then we're generating a bunch of equivalencies and we're using those equivalencies to then do the addition and subtraction. So yeah, kind of cool.
Yeah. So today we're going to do a similar thing, but with a different model. And the model is a clock. Ta-da. Using time, right?
Yeah. All right. So let's get at it.
Okay.
Let's do a little bit of finding equivalencies, and then we'll dive right into addition and subtraction again.
Okay. So I'm going to start you off with just thinking about 1/2 using a clock model.
All right. So back to the operator meaning or the operator interpretation of rational numbers. I'm going to think about 1/2 of a clock or 1/2 of an hour or 1/2 of 60 minutes or 1/2 of sort of that clock face as I think about it. So let's see, I just wrote down the fraction 1/2 equals, and I could think about that 1/2 as 30 minutes out of the total 60 minutes. And what I wrote was 30 60ths or 30 fraction bar 60. Now, as I describe what I'm doing today, I know that I'm going to struggle a little bit to describe the fractions because I'm going to use some words, but actually write something different, perhaps. And so I want you to know that when I'm saying some words, what I'm writing. In other words, when I say 30 60ths, I didn't write the word 30 and then the word 60ths. I wrote 30 fraction bar 60. I'm going to be tempted because of old habits to say 30 over 60. Mm-hmm. So before we move too much further on, I'm going to explain why I'm not using that positional word over to describe the fractions. Because we're all learning mathematics as a second language, right?
Mm-hmm.
So as we are learning mathematics as a second language, we want to use vocabulary, words that mean what we say, not have connotations or meanings that could trip us up or get us thinking about other things or that aren't particularly helpful. Over is one of those words that isn't particularly helpful, in describing fractional relationships. It might be helpful in describing what the fraction looks like the numbers, the numerals I'm writing on the page, the way the fraction itself, the representation looks like, but not the, I shouldn't even say it's so complicated to use these words, not the actual fraction, not the actual relationship. So the relationship of 1/2 or the relationship of 30/60 is all about 1/2 of the object or 1/2 of the set, or 30 minutes out of 60 minutes. It's not about 30 over 60. Over doesn't have anything to do with the fractional relationship I'm trying to talk about. It has everything to do with position, like I'm looking around my office. My laptop is over the desk. That's even a dumb thing to say. Like, give me a better one, Kim. Like, what's a good relationship to describe with over?
Gosh, I got nothing.
Wow, my pen is over the paper. It describes position, right? It doesn't describe out of. It doesn't describe the part-whole relationship of fractions. All right, we'll move on. I'm sure I'll think of it. As soon as we get off this podcast, I'll think of a much better over relationship that I could have done. So 1/2 could be 30 minutes out of 60 minutes. And I write that as 30/60, 30 fraction bar 60. It could also be thought of in terms of other chunks, not just minutes, but I could think about, say, a quarter of an hour. How many quarters of an hour are in a half of an hour? Well, there's like 2 of them, right? Like sort of picture the minute hand going down to the 15 minutes and then going down to the 30 minutes. And there's those 2 15-minute chunks in there, or 2 quarter hours. So I could also say 1/2 is equal to 2 quarter hours out of the 4 quarter hours in a whole hour. So I just wrote 2 out of 4, or 2/4. But that 2/4 isn't just me going, let's say 2/4 is equivalent to 1/2. It's me thinking about 2 quarter hours out of 4 quarter hours. What other chunks could I think of? I could think of terms of 10-minute chunks. So if I'm thinking about 10-minute chunks and I want to think about a half of an hour, how many 10-minute chunks are in a half of an hour? Well, I can think of 3 10-minute chunks out of the 6 10-minute chunks in the whole hour. Right. So I just wrote 3/6, 3 fraction bar 6, because I've got 3 10-minute chunks out of the 6 10-minute chunks. Let me see if I can think of any more. One more. I can think of 5-minute chunks. So 5-minute chunks, if you think about a clock, 5-minute chunks are kind of where that minute hand hits every 5 minutes, or the numbers on the clock, right? So if the minute hand goes to the 1, 5 minutes has gone by. If the minute hand goes to the 3, 15 minutes have gone by, or 3 5-minute chunks, right? If I'm on the 15.
Yep.
But I want to be on the 6, right? Because we decided we're at a half an hour. So the half an hour, if that minute hand has gone all the way down to the 6, how many 5-minute chunks? 1, 2, 3, 4, 5, 6, right? I'm on the 6. So I could think about 1/2 of an hour as 6 5-minute chunks out of the, let's see, total 5-minute chunks, 12 5-minute chunks. So I just wrote 6/12, but I'm meaning 6 5-minute chunks out of 12 5-minute chunks. So I can think about different chunks of numbers. You might be a little bored with 1/2 because 1/2 is like so obvious. So we probably better do a more interesting one. Are you ready, Kim?
Sure.
I'm going to give you 1/3. How can you think about 1/3 on a clock? What are some equivalent fractions that you can think about with time or with a clock?
Okay. I'm going to use some of the chunks that you just mentioned, if that's okay. So I'm going to go with, 1/3. And I'm going to think that is equivalent to 20/60ths.
Okay, why?
Because 1 20-minute chunk out of 3 20-minute chunks makes that hour. So
nice.
1 20-minute chunk out of 3.
And the 60 minutes is the total minutes, right? So 20 minutes out of 60 minutes is equivalent to 1/3.
Yep, and that's the fraction, equivalent fraction I wrote down, 20/60ths.
Okay.
I'm going to go with, it's also equivalent to 2/6, because 2 10-minute chunks out of the 6 10-minute chunks in the hour.
And 2 10-minute chunks, because you're on that 20 minutes. That's 2 10 minutes. Okay.
Let's go 5-minute chunks. So 5-minute chunks are nice for me because it's marked clearly on the clock. And so I'm going to say 4 5-minute chunks out of the 12 5-minute chunks.
And you could kind of think of that
of the clock.
Yeah, sorry.
That's okay.
And a third of a clock you can almost think of as a peace sign, right? And if you sort of draw that peace sign on a clock, it's kind of up at the 12 and then down at that 4, right? Down at the 4. And you just said it was 4 out of the total 12 5-minute chunks. Yeah, so 4 twelfths. Cool. I like it.
All right. Let's do one more. How
Okay.
about if I give you a fourth?
All right, a fourth. So again, using that operator meaning, I'm going to think about a fourth of an hour. So a fourth of an hour is 15 minutes out of the total 60 minutes. So I just wrote down 15 out of 60, 15 60ths. Let's do 5-minute chunks. A fourth of an hour is on the 15, like we just said. So that's the 3. That's like the 3 o'clock, 3 5-minute chunks. So that's 3. You should see my hand. I'm like ticking over 5, 10, 15. I just realized I was doing that with my hand. 5, 10, 15. So I'm at the 15. That's the 3 out of the total 12. So I just wrote down 3 twelfths. Okay. Let's see. We also did 10-minute chunks. You mind if I go there?
Sure.
Okay. So a fourth of an hour, 15 minutes, but I want to do 10-minute chunks. How many 10-minute chunks is 15 minutes? I'll let everybody think about that for a second. 10-minute chunks, 15 minutes. Is that 1.5 10-minute chunks? And how many 10-minute chunks in the whole thing? There's 6 of them, right? So is that 1.5 sixths? Yeah. And that can actually be kind of helpful. And we might see that pop out as we do some more clock equivalencies to help us think about adding and subtracting fractions. Sometimes it can be fun to have something like 1.5 sixths. Now, let me just talk about that for a second. Sometimes in traditional education, we have told students, no, you can't have a decimal and a fraction in the same representation. I'm going to submit that that is completely by convention. Like we have decided that as a mathematics, maybe just even teachers, because it's easier to grade if we don't do that. I don't know. I don't think there's anything wrong with writing 1.5 sixths or thinking about 1.5 10-minute chunks out of the 6 10-minute chunks. I think it's brilliant and it is going to help us build proportional reasoning. And so I want to do it. I'm going to give credit to very first seeing that to Kathy Fosno when I was learning about using a clock to think about fractions. And she sort of threw that out as a possibility. And I was like, yeah, absolutely. Like we can absolutely think that way. Right. So I would agree with her, especially from my higher math perspective. I think it's a fine thing to do. Okay, so now that we have some equivalencies with a few fractions, we better get right at doing some adding and subtracting, yeah?
Yeah. Okay, so let's use what you just came up with. Okay, so let me ask you 1/3 plus 1/4.
Okay, so I just totally wrote those down so I can kind of hang on to what I'm doing. So if I'm going to think about a third plus a fourth, maybe the first thing I'm going to note is notice how money would not be a great model right now.
Oh yeah,
because a third of 100, that's that not a third of a dollar, not so delightful. So bam, I want to go to a clock because it's going to be much nicer. Okay, right. So a third on a clock, we decided that was sort of the 20-minute mark. So I'm going to think about it in terms of minutes. So that's like 20 minutes out of the 60 minutes, 20 60ths, and a fourth of a clock, a fourth of an hour, is like 15 minutes. So 15 60ths. So I've got 20 60ths plus 15 60ths is 35 60ths. That would be one way to think about it. Okay. But let's be flexible and see if we can think about it not just in terms of minutes. However, notice that I'm not, and in fact, notice in all of this that what we're not doing is pushing for the least common denominator. We are actually letting students use whatever denominator makes sense. And then what we're pushing for is, can you be flexible? Like, can you think about it in terms of other denominators so that you get better at the other denominators, really, which means we're pushing for equivalencies. Like we're trying to get kids better and better at different equivalencies, at thinking about different denominators. So let's see, a third plus a fourth. I did minutes. Let's think about 5-minute chunks. Yeah, let's go 5-minute chunks. So a third of an hour is like at the 15. And so that's like, I'm doing it again. I'm ticking my hand down. That's like at the 3 o'clock. So that's 3 out of the 12 5-minute chunks. And a fourth of an hour, that's like, oh wait, that's a fourth of an hour. Sorry. A third of an hour is at the 20. So that's 4 twelfths. 4 twelfths. The fourth of an hour is 3 twelfths. Oh, that's funny because there's that little interesting reciprocal relationship kind of going on there.
Right.
So I've got a third of an hour is 4 twelfths and a fourth of an hour is 3 twelfths. And so that would be 7 5-minute chunks out of the 12 5-minute chunks, or 7/12. But I really, that was fine. But what I really want to do is I have a little bit of fun with the 10-minute chunks quickly. So a third of, again, we're doing a third plus a fourth. So a third of an hour, that's at the 20. So that's like 2 10-minute chunks out of the 6 10-minute chunks. So I've written 2/6. And then a fourth of an hour, that was that fun 1.5-minute chunks out of the 6, 1.5 10-minute chunks out of the 6 10-minute chunks. So now I've got 2/6 plus 1.5/6 is 3.5/6. Nice, nice. And if I can think about 3.5 10-minute chunks, I can think about 3 10-minute chunks is puts me on the 6, right? Puts me on the 30 minutes. And then a half of a 10-minute chunk is another 5. So that's like 35 minutes. And that's what I got. I got 35 out of 60. And also that 7 out of 12 also lands me on that 3.5/6. Pretty cool.
Well done.
So, Kim, thank you. You know that we have a mutual acquaintance named Jordan, and we love Jordan. And Jordan, if you ever listen to this, thank you so much for letting us study you, thinking over time. Jordan was Kim's student in 3rd and 4th grade. He had Kim in 3rd grade, and then Kim looped with her students and had him in 4th grade. And we were able to sort of magically, or by the grace of God, it's kind of the way I fall, get video of him in 2nd grade because his teacher videoed her class in 2nd grade. And then we got video of Jordan in 3rd and 4th grade because Kim had him and we were videoing her kids at that point. And then later, when I realized I had him in 2nd grade and in 3rd and 4th grade, then I went back and grabbed him in 5th grade and 6th grade. And we even have video of him in 10th grade. And so I want to tell you about that video that we took of him in 10th grade today a little bit, because I realized right around that time that I had video of Jordan at all these places, but I didn't ever have him doing any fraction work. So I realized 10th grade was a little bit old, to like do just fraction work, but okay, who cares? I decided to go grab him. So I knew his mom from church. And so I called her up and I said, hey, do you mind if we video Jordan? And she's like, no problem. And so I did. I literally just popped in on this poor 10th grade kid and said, hey, do you mind if we video again? He's a little shy. He's great, kind of shy grin. And he's like, no, it's fine. And so I said, hey, do you ever remember doing a clock model with fractions? And he looked at me and he goes, Miss Harris, it's been a long time since I've done fractions. And I was like, it's okay. Totally. Don't worry about it. We turned the camera on. And I said, hey, Jordan, what can you tell me about a third? How did I even ask it? I think I just said the fraction 1/3, but on a clock. And he kind of thought about a third on a clock a little bit, kind of like we just did. And then I said, how about a fourth on a clock? And he thought about it a little bit, kind of like we just did. And then I said, so can you use that to help you think about a third plus a fourth? And I'll never forget what he did. He kind of looked up, how you sort of look up when you're kind of thinking. And he goes, well, let's see, a third, 4, and a fourth, 3, and 3 plus 7, 7/12. I mean, it was just like this. He just like thought through it.
Yeah.
It's just 7/12. And then I was like, whoa, dude, what did you just do? And then it took him a sec to describe. He's like, well, a third of a clock is like 20 minutes. And so that's like on the 4. And a fourth of a clock is like 15 minutes. So that's like on the 3. And 3 plus 4 is 7. So 7/12. And it took him far longer to describe what he was thinking about than to just actually do it. It was brilliant to watch him just think and reason using relationships. And one of the reasons he can do that is because he learned from the master when he had Kim and our colleague in 2nd grade to think and reason about math. And so he learned he could just think and use what he knew about math. And it's an awesome video. Maybe we'll put in the show notes. Well, why not? We'll put in the show notes the video that we have posted on YouTube where you can go watch Jordan actually do that. Notice when you watch the video, we're in his house. You'll see the vacuum behind him. Like we are totally right there in his house. Thank you, Jordan, for being willing to let us study you and how you think as you were growing up. We really appreciate that. So very cool. All right, we got a lot more to talk about with fractions on a clock. So we're going to do more of that next week and have a lot of fun with not just unit fractions. You heard us talk about unit fractions today where the numerator is 1. Let's do some work next week on a clock where we think about non-unit fractions and even mixed numbers and all the things. So stay tuned for next week where we're going to have a lot of fun. More fun with fractions because fractions are our friend, especially when we think about money and a clock model.
But before we end, I want to ask, what denominators do you think would work well for a clock model? We talked about denominators for money model. So be thinking, what would work well for a clock model? And we'll talk more about that next week.
Excellent. All right. Remember to join us on Math Strat Chat on Facebook, Twitter, Instagram on Wednesday evenings, where we throw out a problem and check out strategies from around the world.
If you find the podcast helpful, would you please rate it and give us a review? That way more people can find it wherever they get podcasts.
And don't forget that we are collecting your questions that you want answered. Send those to kim@mathisforgettable.com. We're going to tackle them in an upcoming episode coming soon. So send them in quickly. So if you're interested to learn more math and you want to help yourself and students develop as mathematicians, don't miss the Math is Figureoutable podcast, because math is figureoutable.